There is a line on this planet that should not exist. It is not drawn on any ancient map. It is not carved into stone or inked onto parchment. And yet, when modern instruments trace the surface of the Earth with cold mathematical precision, this line quietly emerges, curving, continuous, and unnervingly precise. It slips across deserts and oceans alike, passing close to places humanity has regarded as sacred, mysterious, or monumental for thousands of years. The Great Pyramid of Giza, the Nazca Lines, Machu Picchu, Easter Island. Civilizations separated by vast distances, isolated by oceans, divided by time, yet brushed by the same invisible arc. At first glance, it feels like coincidence. At second glance, it feels like something else entirely. Because this line is not mystical, it is mathematical. To understand why it unsettles us, we must first strip away the romance and confront the geometry of the Earth itself. Our planet is not flat, not perfectly spherical, but close enough that its surface obeys a rigorous set of rules. On a sphere, the shortest distance between 2 points is not a straight line as we imagine it on a map, but a curve that wraps around the globe. These curves are known as great circles, the largest possible circles that can be drawn on a sphere, slicing it cleanly through its center. Every commercial flight you've ever taken follows one. Every satellite orbit is calculated using them. GPS systems, missile trajectories, intercontinental communication, our most advanced technologies rely on this ancient geometry. Great circles are not speculative. They are the backbone of modern navigation, and this is where the discomfort begins. When researchers began plotting the precise geodetic coordinates of ancient sites, using the same spherical mathematics that guides aircraft and spacecraft, something unexpected appeared. Certain monuments, chosen not for convenience but for their undeniable cultural significance, fell astonishingly close to the same great circle paths. Not perfectly aligned, not mathematically exact, but close enough to raise eyebrows among statisticians, engineers, and historians alike. The Great Pyramid, standing with silent authority on the Giza Plateau, sits within a narrow margin of one such path. Thousands of kilometers away, the Nazca Lines, vast geoglyphs etched into the Peruvian desert, hover near that same curvature. Farther still, Machu Picchu clings to the Andes, while Easter Island stares out across the Pacific, isolated and enigmatic. Different builders, different purposes, different eras, yet their coordinates whisper of a shared geometric proximity. It is important to be precise here. No ancient civilization is known to have possessed satellites, global maps, or the ability to measure Earth as a sphere with modern accuracy. No inscriptions describe a planetary grid. No texts outline a worldwide system of alignment. These facts matter. And yet, the geometry does not disappear simply because we are uncomfortable with its implications. The temptation at this point is to leap toward grand conclusions, lost civilizations, forgotten technologies, Atlantean myths reborn as mathematics. But this documentary will not do that. Mystery does not require exaggeration. In fact, exaggeration weakens it. Instead, we begin with a simpler, more unsettling observation. The Earth itself imposes patterns on anything built upon it. On a sphere, there are only so many ways to arrange points before relationships emerge. When human beings repeatedly choose specific kinds of locations, high ground, solstitial sight lines, tectonically stable regions, places where sky and land converge, those choices are not random. They are constrained by physics, astronomy, and geography, and yet even acknowledging this, something still lingers. Because these ancient builders were not ignorant. They were not stumbling blindly across landscapes. They watched the sky with obsessive attention. They tracked the sun, the moon, the stars. They built with cardinal directions in mind. They encoded time into stone. Long before equations were written down, geometry was lived, walked, measured with rope and shadow, memorized through ritual. A great circle does not announce itself to the eye. It cannot be seen from the ground. You do not stand upon it and feel its presence. And that is what makes the question so compelling. If these alignments mean nothing, they dissolve under scrutiny. If they mean something, that meaning must be subtle, indirect, and deeply human. Consider this. Ancient cultures did not need to know the Earth was a sphere to interact with it as one. Sailors learned the curvature through the disappearance over the horizon. Astronomers inferred scale from shadow and angle. Geometry at its core is not about tools, it is about relationships. Between points, between cycles, between the observer and the observed. Modern analysis shows that some alignments are inevitable. With enough points on a globe, some will cluster, some will line up, some will seem uncanny. Statistics warns us of confirmation bias, the human tendency to notice patterns that confirm our expectations and ignore those that do not. This warning is valid, necessary even, but statistics also do not erase wonder. Because what is being plotted here is not random noise. These are sites of extraordinary effort, planning, and symbolic weight. They were chosen deliberately, built deliberately, and remembered deliberately. The question is not whether a perfect global line exists. It does not. The question is why we are so compelled by the idea that it might. Perhaps the line is not something the ancients drew across the earth. Perhaps it is something they traced within their minds, a way of thinking that linked land to sky, place to purpose, humanity to a larger order, a way of situating themselves within a cosmos that felt vast, alive, and structured. The line, then, is not an artifact. It is an invitation to look again at what we think ancient people knew, an invitation to examine the tools we use to judge intelligence across time, an invitation to confront the possibility that meaning does not require global coordination to feel global in its impact. So we stand at the beginning of this investigation, not with answers, but with a choice: to dismiss these alignments as a coincidence and move on, or to follow the mathematics, the archaeology, and the philosophy wherever they lead, without surrendering rigor and without surrendering wonder. Whether this line is an accident of geometry or the shadow of an ancient way of seeing the world, it asks something of us. What patterns are we still blind to? And if this journey into the deep structures of our past resonates with you, if you find value in questioning easy answers and sitting with difficult mysteries, consider staying with us by subscribing. What comes next only grows more unsettling. To follow that line any further, we must abandon intuition and step into measurement, because whatever meaning we eventually assign to alignments, monuments, and ancient intent, the stage on which all of it unfolds is not mythic. It is physical, quantifiable, relentlessly precise. The Earth is not an idea, it is an object. For most of human history, the planet felt infinite beneath our feet, flat enough to walk without question, vast enough to defy comprehension. Yet long before satellites or spaceflight, careful observers began to realize something unsettling. The Earth could be measured, not guessed, not imagined, measured. The earliest clues came from shadows. In the 3rd century BCE, Eratosthenes noticed that at noon on the summer solstice, the sun illuminated the bottom of a well in Syene, while casting a measurable shadow in Alexandria. From that single discrepancy, an angle no wider than a few degrees, he inferred the curvature of the Earth and calculated its circumference with startling accuracy. No global survey, no advanced instruments, just geometry, patience, and trust in a rational universe. That calculation still stands within a small margin of error. Today, we know the Earth is not a perfect sphere. It bulges slightly at the equator, flattened at the poles by its own rotation. Technically, it is an oblate spheroid, an inconvenient shape that complicates every calculation. Its equatorial radius measures approximately 6,378 kilometers. Its polar radius is slightly less. The circumference around the equator stretches just over 40,000 kilometers. These are not approximations born of theory. They are values refined through centuries of observation, triangulation, and satellite telemetry. The Earth also tilts. Its axis leans roughly 23.5 degrees away from perpendicular, a quiet inclination that governs the seasons, the migration of climates, the rhythm of ice ages, and the arc of the sun across the sky. This tilt is not symbolic, it is mechanical, and yet it shapes mythologies as powerfully as it shapes weather. To measure a planet like this, to map it accurately, to navigate it reliably, required the birth of a discipline so fundamental that modern civilization collapses without it: geodesy. Geodesy is the science of measuring Earth's size, shape, orientation in space, and gravitational field. It is not glamorous. It does not chase mysteries. It enforces constraints. Every bridge, boundary, satellite orbit, submarine cable, and GPS coordinate depends on it. Without geodesy, global positioning systems drift into nonsense. Borders blur. Navigation fails. Geodesy treats Earth as it is, not as we wish it to be. And within geodesy lies a concept that feels deceptively simple: the Great Circle. On a plane, the shortest path between 2 points is a straight line. On a sphere, that intuition fails. The shortest path becomes a curve that hugs the surface, one that appears bent when flattened onto a map, but is mathematically straight in 3 dimensions. These curves are unavoidable. Every sphere, no matter its size or composition, possesses an infinite number of them. The equator is one. So is every meridian that slices through the poles. Any plane passing through the Earth's center defines a great circle. No exceptions. No mysticism, just geometry. This is why aircraft routes arc across maps instead of running horizontally. Why do satellites trace looping paths across the sky? Why long-distance navigation ignores the grid lines we draw and obeys a deeper structure beneath them? So when ancient sites appear to lie along these curves, the first response must not be awe, it must be discipline. Because on a sphere, patterns are cheap. With enough points scattered across a globe, some will inevitably align along great circles. This is not controversial, it is mathematically guaranteed. Choose any 2 points on Earth, and there is exactly one great circle connecting them. Add a third point, and the odds that it lies close to that same curve are small, but not vanishing. Add dozens of points, and coincidences accumulate, especially when the points are not random, but chosen for prominence, accessibility, or symbolic importance. This is where science draws a hard line. If alignments exist, they cannot be judged emotionally. They cannot be validated by how compelling they feel, how elegant they appear, or how well they fit a narrative of lost wisdom. They must be tested statistically. How many sites were considered? How many were ignored? How close is close? How many similar alignments exist that no one talks about because they lead nowhere interesting? These questions are not obstacles to wonder. They are its foundation. Because the real tension does not come from whether geometry can produce alignments. It can, effortlessly. The tension arises from something more subtle: why geometry keeps reappearing in human culture long before it was formalized. Long before Earth was measured as a spheroid, ancient builders oriented structures to cardinal directions with uncanny accuracy. They divided circles into equal arcs, they embedded ratios into stone, they marked solstices, equinoxes, and lunar standstills. They encoded cycles of days, years, generations into architecture that outlasted the societies that built it. They did not need global coordinates to do this. They needed only observation, repetition, and memory. Geometry, in this sense, is not an invention. It is a discovery, a recognition that space behaves consistently. Those angles repeat, those cycles return. Those relationships hold whether or not anyone writes them down. Modern geodesy formalizes this recognition. It strips it of metaphor and demands precision. But it does not negate the ancient impulse that preceded it. In fact, it confirms something quietly profound. The universe is ordered enough to be mapped, but vast enough to never be fully possessed. And so we arrive at the scientific tension at the heart of this investigation. On the one hand, Geometry is universal. Any intelligent species inhabiting a spherical world would encounter great circles, axial tilt, curvature, and horizon limits. There is nothing uniquely human about these constraints. On the other hand, humans do something peculiar with them. We ritualize them. We turn angles into symbols, directions into meaning, cycles into stories. We align stone not only to the sky, but to ideas about origin, destiny, and continuity. We embed mathematics into myth and myth back into mathematics until the two become difficult to separate. This is why purely dismissing ancient alignments as a coincidence feels incomplete. Not because coincidence is insufficient, but because it ignores intent. Ancient builders were not scattering monuments randomly across the globe. They were responding to landscapes, skies, and cultural imperatives with deliberate choices. Those choices did not require knowledge of Earth's radius in kilometers, but they did require an intuitive grasp of order. The danger lies in overcorrection, in assuming that because geometry is universal, it must therefore be meaningless. That is because patterns can arise naturally, therefore they should not be ignored. Science does not ask us to abandon curiosity, it asks us to refine it. The Earth can be measured. That is no longer in question. Its curves are predictable. Its geometry is unforgiving, and any claim about global alignment must pass through that filter or be discarded. But once it has passed through, once emotion has been stripped away and statistics applied, we are left with a quieter, more enduring question. If geometry belongs to the universe itself, and if humans across time and culture keep returning to it, not just to measure the world, but to explain their place within it, what does that say about us? Why do circles, axes, and alignments feel instinctively meaningful? Why does a planet that can be reduced to numbers continue to inspire symbols? And if geometry is universal, perhaps the real mystery is not whether ancient people traced lines across the Earth, but why, when faced with an indifferent cosmos, the human mind insists on finding order within it. In 1921, there was no talk of planetary energy grids, no speculation about lost super-civilizations, and no cultural fascination with invisible forces crisscrossing the Earth. The idea that would later ignite all of that began instead with something far more modest: a man, a map, and a way of looking at the landscape that was unusually systematic for its time. Alfred Watkins was not an archaeologist by training. He was a British antiquarian, a businessman, and a careful observer of the English countryside. His interest lay in old roads, place names, and the remnants of pre-industrial landscapes, features that were rapidly disappearing under modern development. What distinguished Watkins was not mystical inclination, but method. He believed the past could be reconstructed through patterns embedded in geography if one was willing to look without romantic assumptions. Watkins' insight came while studying maps of Herefordshire. As he later described it, he noticed that certain ancient features, standing stones, hilltops, churches, burial mounds, old crossroads, appeared to fall along straight lines when viewed from above. These lines were not obvious when walking the terrain, but they became apparent when landmarks were plotted cartographically. Watkins called these alignments lays, borrowing from Old English place name elements that referred to clearings or open land.
Crucially, Watkins did not propose anything supernatural.
His hypothesis was grounded in landscape archaeology, though the term had not yet been formalized. He suggested that these alignments represented ancient trackways, straight paths laid out by early inhabitants to navigate dense forests and uneven terrain. Before roads were paved and before hedgerows divided the land, long-distance travel required clear sight lines. A traveler could move from hill to hill, marker to marker, maintaining direction by keeping visible landmarks aligned. This idea was entirely practical. In an era without compasses, maps, or standardized surveying tools, straight-line navigation using prominent features would have been efficient and repeatable. Watkins argued that these paths predated Roman roads and were later reused, overwritten, or obscured by subsequent development. Churches, he suggested, were often built atop older sacred or navigational sites, not because of mystical continuity, but because those locations were already central and well known. Watkins' method relied on direct observation and early statistical reasoning. He compared multiple maps, documented repeated alignments, and tested whether the patterns held across regions rather than appearing only in isolated cases. His 1925 book, The Old Straight Track, laid out this argument in detail. It included diagrams, measured distances, and references to place names, many of which contained linguistic hints of antiquity. There was nothing extraordinary about this approach by modern standards, but at the time it challenged prevailing archaeological assumptions. The idea that prehistoric people built long, straight routes across landscapes ran counter to the belief that early societies moved only locally and lacked coordinated planning. Watkins suggested the opposite, that ancient communities possessed a functional understanding of geometry, line-of-sight surveying, and spatial organization. It is important to emphasize what Watkins did not claim. He did not suggest global coordination. He did not claim these lines extended across continents. He did not invoke earth energies, magnetic forces, or cosmic alignments. His lays were regional, practical, and human in scale. From a scientific perspective, Watkins's hypothesis can be understood as an early form of spatial analysis. He was identifying correlations between known archaeological features and testing whether their arrangement deviated from randomness. Modern archaeology now routinely performs similar analyses using geographic information systems, statistical clustering, and spatial autocorrelation metrics. In that sense, Watkins was ahead of his time. However, his conclusions were not universally accepted. Critics argued that when many landmarks exist in a limited area, some alignments are inevitable. If one selects only features that support a hypothesis while ignoring others, patterns can appear where none were intentionally created. This critique remains valid today and applies to any form of pattern analysis. Even so, Watkins's ideas remained largely within the bounds of serious antiquarian debate for decades. They were discussed, challenged, refined, and in some cases dismissed, but they were not sensationalized. That changed after his death. In the mid-20th century, particularly after the Second World War, cultural attitudes toward ancient knowledge began to shift. Interest in mysticism, alternative histories, and hidden systems of meaning grew alongside skepticism toward institutional authority. In this environment, Watkins' straight lines across the landscape took on a new identity. The key transformation was conceptual. What Watkins had framed as trackways and sightlines were reinterpreted as conduits. Lines became forces, alignment became intention. The Earth itself was recast as an active participant rather than a passive surface. By the 1960s and 1970s, ley lines were increasingly described as channels of Earth energy, a term that lacked a clear physical definition but carried intuitive appeal. Writers and enthusiasts began linking lays to dowsing, psychic sensitivity, ancient rituals, and later, extraterrestrial hypotheses. Sites along these lines were no longer simply navigational markers, they became nodes in a planetary network. From a scientific standpoint, this was a decisive departure. No measurable physical field corresponding to ley line energy has ever been detected. Earth's known forces, gravity, magnetism, tectonics, do not align with proposed ley networks. Magnetic field lines shift over time and do not form stable straight paths across continents. Gravitational variations are irregular and driven by mass distribution, not surface landmarks. Attempts to correlate ley lines with measurable geophysical phenomena consistently fail under controlled conditions. The reinterpretation persisted not because of evidence, but because of narrative power. Straight lines appeal to the human mind. They suggest intention, intelligence, and design. When combined with ancient monuments whose original purposes are partially lost, they create a sense of hidden order just beyond reach. This psychological dimension cannot be ignored. Humans are exceptionally skilled at detecting patterns, even in noisy data, a trait that has evolutionary advantages, but also cognitive costs. The transformation of ley lines illustrates this vividly. What began as an observational hypothesis rooted in landscape archaeology became over time a symbolic framework onto which broader cultural anxieties and aspirations were projected. The same lines that once explained how people moved through forests were now said to explain how consciousness moved through the planet. From a scientific perspective, this expansion required increasingly selective evidence. Alignments were extended beyond regional scales to global ones, despite Watkins never proposing such a reach. Statistical rigor gave way to visual impression. Coincidence was reframed as confirmation. Modern researchers examining this shift often point out that the method changed even when the terminology did not. The word ley remained, but its meaning drifted from measurable geography into speculative metaphysics. This drift matters because it complicates how the original idea is evaluated. Critiques aimed at mystical ley lines often dismiss the entire concept, inadvertently discarding Watkins' more grounded observations in the process. Conversely, defenders of ley lines sometimes invoke Watkins' name to lend credibility to claims he would not have recognized. In scientific terms, this is a category error. Watkins proposed a hypothesis about human behavior in specific landscapes. New Age interpretations proposed a theory about Earth itself. These are not competing explanations of the same phenomenon. They are explanations of entirely different things. Understanding this distinction is essential. Without it, the discussion collapses into false dichotomies. Either ley lines are mystical and therefore false, or they are ancient and therefore profound. The reality is less dramatic and more informative. Watkins showed that humans impose order on space through movement, memory, and repetition. Later interpretations revealed how easily that imposed order can be reimagined as something external and autonomous. What remains unresolved is not whether ley lines channel energy, they do not, but how a sober, observational idea became a vessel for far more controversial claims. How a study of paths through land transformed into a belief in paths through reality itself. And that transformation raises a deeper question, one that extends beyond Watkins and beyond ley lines altogether. When does the search for patterns cross the boundary from explanation into belief? And why does that boundary seem so difficult to see while we are standing on it? By the middle of the 20th century, the idea of ley lines had quietly crossed a threshold. What began as an attempt to understand how ancient people moved through landscapes was no longer confined to archaeology or cartography. It had entered myth. This transformation did not happen all at once, nor did it occur because of a single discovery. It unfolded gradually, shaped by cultural currents that were already in motion: distrust of authority, fascination with hidden knowledge, and a growing sense that modern science, for all its power, had stripped the world of meaning. Into that vacuum, ley lines expanded. The first shift was subtle. Instead of being interpreted as old trackways or sightlines, leys were reframed as something intrinsic to the Earth itself. The land was no longer passive terrain traversed by humans. It became an active system, laced with invisible forces. These forces were often described vaguely as Earth energies, a term that sounded scientific but carried no agreed-upon definition. From a physical standpoint, this was a critical departure. Earth does possess measurable fields, gravitational, magnetic, electrical, but none of them behave in the way ley line proponents suggested. Magnetic field lines curve, drift, and reverse over geological time. Gravitational variations correspond to mass distribution, not surface landmarks. Electrical currents in the Earth are diffuse, transient, and influenced by solar activity. None form stable, straight channels connecting ancient monuments. Yet the language of energy persisted, precisely because it was non-specific. It borrowed authority from physics without submitting to its constraints. As a result, almost any perceived sensation, a feeling at a site, a subjective experience, an anecdotal report, could be interpreted as confirmation. The second expansion followed naturally. If ley lines were channels of energy, then they could also be channels of movement. By the late 1950s and 1960s, as public interest in unidentified flying objects surged, some writers proposed that UFOs followed ley lines as navigational routes. The logic was circular but compelling. UFO sightings clustered near certain landmarks. Those landmarks lay on ley lines. Therefore, ley lines must guide extraterrestrial craft. From a scientific perspective, this claim collapses immediately. UFO sightings, now more carefully termed UAPs, or unidentified anomalous phenomena, do not cluster along straight global paths when analyzed systematically. Reports are unevenly distributed, influenced heavily by population density, media coverage, and reporting mechanisms. Moreover, there is no physical reason an advanced craft would rely on surface-based alignments rather than inertial navigation, stellar reference frames, or satellite-like positioning systems. The association persisted anyway, because it transformed ley lines from historical artifacts into cosmic infrastructure. They were no longer just old paths. They were highways between worlds. Atlantis soon followed. Plato's account of Atlantis had long occupied a peculiar place in Western thought, part allegory, part obsession. In the late 20th century, ley lines were drawn into this narrative as supposed remnants of a lost global civilization. According to this interpretation, Atlantis, or a similar advanced culture, had once mapped the Earth, understood its geometry, and built a worldwide network of monuments aligned along ley lines. The destruction of that civilization, often attributed to a cataclysm around the end of the last ice age, scattered this knowledge, leaving only fragments behind. Here again, the scientific objections are straightforward. There is no archaeological evidence of a global civilization with shared construction methods, writing systems, or technologies dating to 12,000 years ago. Civilizations that did exist at that time show regional variation, gradual development, and no signs of worldwide coordination. Monumental architecture emerges independently in multiple locations thousands of years apart, shaped by local resources and cultural needs. Geologically, the proposed sudden destruction of such a civilization also lacks evidence. While the end of the last ice age did involve climate shifts and sea level rise, these changes occurred over millennia, not in a single catastrophic event capable of erasing a global society without trace. Despite this, Atlantis became a convenient explanatory container. It unified disparate mysteries under a single narrative and relieved proponents of the burden of proving continuity. Any gap in evidence could be attributed to loss, submergence, or suppression. The final extension of ley lines moved inward from the planet to the mind. Psychic phenomena, telepathy, heightened intuition, altered states of consciousness were increasingly linked to locations said to lie on ley lines. Sacred sites were reinterpreted as amplification points where human awareness could supposedly interact with Earth's energies. This claim proved especially resilient because it resisted falsification. Subjective experience became both evidence and outcome. From a scientific standpoint, this is where the framework fully departs from testable reality. Consciousness, while still not fully understood, has no demonstrated mechanism by which it couples selectively to geographic alignments. Neurobiology, cognitive science, and physics offer no support for location-based psychic amplification tied to straight-line patterns across the Earth. Yet culturally, this idea flourished. It re-enchanted landscapes stripped of meaning by industrialization. It offered personal access to mystery without requiring institutional validation. And it positioned believers as participants rather than observers. This is where live science and other science-based outlets step in, not to ridicule curiosity, but to clarify where inquiry ends and projection begins. Their critique focuses on two well-established psychological principles: pattern-seeking behavior and confirmation bias. Humans are extraordinarily adept at detecting patterns. This ability evolved because it conferred survival advantages, recognizing predator shapes, seasonal cycles, and social cues. But the same cognitive machinery can misfire. We see faces in clouds. We hear messages in random noise. We connect unrelated events into meaningful sequences. When applied to geography, this tendency becomes particularly powerful. Given enough points on a map, straight lines will appear. Given enough freedom to choose which points matter, almost any pattern can be constructed after the fact. Once a line is drawn, attention shifts to the points that support it, while those that do not are ignored. Confirmation bias then takes over. Evidence that fits the narrative is remembered and shared. Evidence that contradicts it is dismissed or explained away. Over time, the pattern feels increasingly real, not because it is becoming more accurate, but because dissenting data is filtered out. Live science emphasizes that none of this requires deception or irrationality. It is how human cognition works by default. Without rigorous controls, predefined criteria, statistical testing, and independent verification, pattern recognition becomes storytelling. This does not mean that all mysteries evaporate under scrutiny. It means that the form of the mystery changes. Once claims about UFO navigation, Atlantean engineering, and psychic energy are removed because they lack physical mechanisms, archaeological support, or reproducible evidence, something quieter remains: a historical observation, a cognitive tendency, a cultural evolution. The real question is not whether ley lines channel energy. They do not. It is not whether ancient civilizations coordinated globally. They did not. It is not whether UFOs follow invisible paths across the Earth. There is no evidence they do. The deeper question is why these ideas took hold so powerfully once measurement gave way to myth. Why did a hypothesis about ancient roads become a theory about planetary consciousness? Why does geometry, when stripped of equations, so readily become destiny? And perhaps most unsettling of all, if these extraordinary claims collapse under evidence, does that mean the entire mystery collapses with them? Or does it simply force us to confront a different one, less fantastical, but far more revealing about how humans search for meaning in a measurable world? When the search for hidden order on Earth begins to unravel, the instinctive response is to look elsewhere. And long before humans tried to impose lines upon the land, they were already tracing patterns in something far older, far more constant, and far less negotiable. They looked up. The sky was humanity's first map, not metaphorically but functionally. It moved with precision, repeated itself with patience, and revealed cycles that could be trusted when everything on the ground felt uncertain. Long before borders, roads, or coordinates, there was sunrise and sunset, solstice and equinox. The slow procession of stars that returned night after night, generation after generation. This is where a legitimate scientific discipline enters the story, one that does not speculate about lost technologies or invisible energies, but relies on measurement, orientation, and repeatable observation. It is called Archaeoastronomy. Archaeoastronomy studies how ancient cultures understood celestial phenomena and how that understanding was encoded into structures, landscapes, and ritual systems. It sits at the intersection of astronomy, archaeology, anthropology, and physics. And unlike many claims surrounding ley lines, its findings are grounded in demonstrable alignments, statistical analysis, and astronomical reconstruction. The central premise is simple: ancient people paid close attention to the sky, and they built accordingly. One of the most thoroughly studied examples stands on a windswept plain in southern England. Stonehenge. Stonehenge is not mysterious because it is old, nor because its builders lacked written records. It is mysterious because it is precise. The monument's primary axis aligns with the rising sun at the summer solstice and the setting sun at the winter solstice. This is not approximate. It is not symbolic in a vague sense. It is geometric and repeatable. Modern measurements show that when viewed from the center of the stone circle, the sun rises directly over the heel stone on the longest day of the year. This alignment would have required generations of observation and a clear understanding of the sun's annual movement along the horizon. It also required the ability to fix that knowledge in space, to translate time into stone. Stonehenge was not a calendar in the way we use the term today. It did not count days. It marked thresholds. It anchored human activity to cosmic events that governed agriculture, ritual, and social cohesion. The sky was not a decoration. It was infrastructure. Move thousands of kilometers south and east, and the same principle appears in a radically different cultural context. Ancient Egypt oriented its most monumental structures not only to the cardinal directions with extraordinary accuracy, but also to the stars themselves. The pyramids at Giza are aligned almost perfectly north, south, east, west, with deviations of mere arc minutes, precision that rivals modern surveying. But the orientation did not stop at the horizon. Egyptian cosmology linked the afterlife to the circumpolar stars, those that never set, circling endlessly around the celestial pole. These stars were associated with immortality and divine order. The internal shafts of the Great Pyramid, once dismissed as structural anomalies, are now understood to align with specific stellar regions as they appeared around 2500 BCE. This was not random decoration, it was cosmological engineering. The Egyptians did not imagine the sky as separate from Earth. They saw it as a mirror of order, a realm governed by Ma'at, the principle of balance and harmony. Aligning stone to stars was a way of embedding that order into the human world. Architecture became cosmology made solid. Across the Atlantic, in Mesoamerica, a different civilization reached similar conclusions through entirely independent means. The Maya developed one of the most sophisticated calendrical systems ever known, without metal tools, without telescopes, and without written mathematics as we recognize it today. They tracked the cycles of the Sun, Moon, Venus, and Mars with astonishing accuracy. Their long-count calendar extended tens of thousands of years into the past and future, anchored not to mythology alone, but to astronomical cycles. Mayan cities reflect this obsession with time and sky. Temples and pyramids were oriented to solstices, equinoxes, and planetary events. At Chichen Itza, the Pyramid of Kukulkan is aligned so that during equinoxes, shadows cast by the setting sun create the illusion of a serpent descending the staircase, a visual effect that occurs only on those days. This was not artistic coincidence. It required an understanding of solar geometry, seasonal timing, and architectural projection. The Maya encoded temporal knowledge into space itself, allowing the sky to announce its own rhythms through stone. Farther south, high in the Andes, the Inca approached the sky not through isolated monuments, but through an integrated spatial system that tied celestial observation directly to social organization. The Inca Seque system radiated outward from Cusco, the imperial capital, in a series of ritual lines connecting hundreds of sacred sites, or huacas. These lines were not straight in the geometric sense, nor were they global. They were relational. Each seque corresponded to specific astronomical events, seasonal markers, and ceremonial duties assigned to different kin groups. The landscape became a living calendar, and the sky provided the reference framework. Mountains, rivers, and shrines were not chosen arbitrarily. They were positioned within a cosmological network that linked time, space, and authority. What makes the Seque system particularly important is that it demonstrates how astronomical knowledge can be embedded socially, not just architecturally. The sky was not only observed, it was organized, remembered, and enacted through ritual movement across the land. None of these cultures shared maps, none shared a language, none shared technology. And yet, all arrived at the same foundational insight. The sky is predictable, and that predictability can anchor human life. This convergence is not evidence of a lost global civilization. It does not require secret knowledge or external intervention. It arises naturally from a shared constraint. Every human who has ever lived beneath this sky has been subject to the same celestial mechanics. The Earth rotates, it orbits, its axis tilts, the stars appear to move, the sun returns. Archaeoastronomy demonstrates that ancient people did not merely notice these patterns, they formalized them. They translated motion into meaning. They built systems that allowed cosmic order to regulate agriculture, ritual, power, and memory. In this light, the idea of a network takes on a different meaning. It is not a network of lines etched into the earth, but a network of reference points shared by all humanity. The sky provided a universal framework long before longitude and latitude. It was the first coordinate system accessible to anyone willing to observe enough. And this reframes everything that came before. If ancient cultures around the world independently align their most important structures to the same celestial cycles, then similarity does not imply contact, it implies constraint. The cosmos itself imposes a limited set of meaningful patterns. Humans, regardless of culture, respond to those patterns in comparable ways. The order we search for on the ground may be a reflection of an order we first learned to trust in the sky. And that raises a question far more profound than whether monuments align along lines on a map. If the heavens provided a shared language long before writing, long before borders, long before maps, then perhaps the deepest connections between ancient civilizations were not terrestrial at all. Perhaps they were written above their heads, night after night, in the only network every human has ever truly shared. For much of modern history, there was an unspoken agreement about how civilization began. First came survival, then agriculture, then villages, then religion, art, and astronomy, slowly, clumsily, and only after food was secure. Knowledge, in this view, was a byproduct of stability. Complexity arrived late. Göbekli Tepe shattered that agreement. Discovered in southeastern Turkey and dated to around 9600 BCE, Göbekli Tepe is older than Stonehenge by more than 6,000 years, older than the Egyptian pyramids by roughly 7,000, older even than pottery, metallurgy, or clear evidence of domesticated agriculture in the region. And yet, it is monumental. Massive T-shaped limestone pillars, some weighing up to 20 tons, stand arranged in circular enclosures. They are carved with reliefs of animals: foxes, snakes, boars, birds, scorpions. The workmanship is deliberate, skilled, and consistent. This was not improvisation, it was planning. What stunned archaeologists was not just the age, but the implication. The people who built Göbekli Tepe were hunter-gatherers according to every conventional model available at the time. They should not have had the surplus labor, social organization, or symbolic framework required to build something like this. And yet, they did. Radiocarbon dating placed the site firmly at the end of the last ice age. Stratigraphy confirmed multiple construction phases over centuries. The enclosures were not accidental accumulations. They were rebuilt, reconfigured, and eventually buried deliberately. This last detail matters. Göbekli Tepe was not abandoned due to collapse or catastrophe. It was intentionally covered with thousands of tons of soil, preserving it like a time capsule. Whoever built it chose to seal it away. From the moment it entered the archaeological record, Göbekli Tepe forced a reconsideration of causality. Perhaps agriculture did not give rise to ritual and cosmic symbolism. Perhaps shared belief systems, anchored in something beyond immediate survival, created the social cohesion necessary for agriculture to emerge. In other words, meaning may have come first. As excavation progressed, attention shifted from the sheer scale of the site to its internal logic. The pillars were not randomly placed. The enclosures followed consistent patterns. The T-shaped forms appeared anthropomorphic, abstracted human figures with arms, hands, and belts carved into their sides. Faces were absent, but posture was implied. These were not gods in the later sense. They were representations of beings, possibly ancestors, spirits, or archetypal figures, embedded within a structured space. And above all, the space was oriented. Researchers began to notice that certain enclosures shared similar alignments. Their entrances, central pillars, and sightlines appeared to correspond to specific directions. This raised a familiar question, but now at a depth of time few had considered before. Was the sky involved? Archaeoastronomical analysis at Göbekli Tepe is still ongoing, and caution is essential. Claims must be tested against horizon profiles, precessional shifts, and statistical likelihood. But several peer-reviewed studies have proposed that some enclosures may align with the rising or setting points of prominent stars as they appeared in the 10th millennium BCE. One candidate that has drawn particular attention is Sirius. Sirius, the brightest star in the night sky, underwent a significant change in visibility at this latitude around the time Göbekli Tepe was constructed. Due to axial precession, the slow wobble of Earth's axis, Sirius would have re-emerged above the horizon after thousands of years of invisibility. Its first heliacal rising would have been a striking and rare event, occurring just before dawn on a specific day each year. In later civilizations, notably Egypt, the heliacal rising of Sirius marked renewal, inundation, and cosmic order. At Göbekli Tepe, some researchers suggest that the orientation of certain enclosures may correspond to the point on the horizon where Sirius first became visible again. This hypothesis does not require advanced instruments or abstract mathematics. It requires patience, intergenerational observation, and a deep attentiveness to the sky. It suggests that the builders were tracking long-term celestial changes subtle enough to escape notice within a single lifetime. Even more striking are proposals linking Göbekli Tepe's animal symbolism to constellations. Some researchers argue that the relief carvings may encode a form of sky lore, animals corresponding not to local fauna alone, but to star patterns. This interpretation remains debated, and rightly so. Symbolism can be read too easily into ambiguous imagery. Yet, the possibility itself is telling. The very fact that such hypotheses are plausible at this age forces a re-evaluation of what early humans were capable of conceptualizing. Göbekli Tepe does not show evidence of writing. It does not present a calendar carved in stone, and yet it suggests a worldview in which time, sky, and ritual were deeply intertwined. Knowledge was not recorded. It was enacted, repeated, remembered collectively. This is what makes Göbekli Tepe so disruptive. It demonstrates that complex symbolic systems can exist without agriculture, without cities, and without formal hierarchies as we define them today. It shows that humans were capable of organizing labor around shared cosmological ideas long before economic necessity demanded it. Importantly, this does not imply a lost global civilization. There is no evidence of advanced technology, no trace of worldwide contact, no sudden appearance of knowledge without precedent. What it implies instead is continuity. Humans did not wake up one day and invent astronomy. They accumulated it slowly through observation passed down orally across generations. They watched the sky change. They noticed patterns too slow for a single lifespan to capture. They built monuments not to dominate nature, but to remember it. Göbekli Tepe represents a pre-agricultural knowledge system, one rooted in ritual, memory, and celestial awareness. It was not science as we practice it today, but it was not ignorance either. It was structured understanding expressed through architecture. And when we place Göbekli Tepe alongside later sites, Stonehenge, Giza, the Maya temples, we do not see a sudden leap in cognition. We see a continuum, a long, patient conversation between humans and the sky, unfolding across millennia. The shock, then, is not that ancient people were sophisticated. The shock is how early that sophistication appears. If hunter-gatherers nearly 12,000 years ago were observing stellar movements, orienting monumental architecture, and embedding cosmological meaning into space, then many of our assumptions about the pace and prerequisites of knowledge are wrong. Civilization may not have created cosmic awareness. Cosmic awareness may have helped create civilization, and that realization leads to an unsettling question, one that archaeology alone cannot answer. If humans were capable of such long-term observation, abstraction, and symbolic encoding at the very threshold of settled life, what else were they watching, tracking, and understanding long before history learned how to write it down? When confronted with claims of hidden planetary networks, the most responsible response is not wonder, but mathematics. Before meaning can be assigned, probability must be consulted. On a spherical body like Earth, great circles are not rare features. They are mathematically unavoidable. Any plane passing through the center of a sphere intersects its surface as a great circle. This means there are infinitely many of them. Every longitude line is a great circle. The equator is a great circle. Countless others exist at every possible orientation. From the standpoint of geometry alone, it would be more surprising if prominent points did not occasionally line up along such curves.
This is where statistical reasoning enters the discussion, not to destroy curiosity, but to discipline it.
Imagine a globe marked with thousands of archaeological sites. Some are famous, some obscure, some are ancient, others relatively recent. If one begins by selecting only the most iconic, Giza, Stonehenge, Machu Picchu, Easter Island, the dataset is already biased. These sites are famous precisely because they are visually striking, geographically dramatic, or symbolically loaded. They are not a random sample of human construction. When a researcher then draws a great circle that happens to pass near several of these landmarks, the human brain does what it evolved to do. It detects a pattern and assigns intention. But probability theory asks a colder question. Given enough points on a sphere and enough possible great circles, how likely is it that some of them will pass near multiple points purely by chance? The answer is extremely likely. This is known as the multiple comparisons problem. When many tests are performed, consciously or unconsciously, some will produce striking results simply due to randomness. If one draws thousands of possible great circles and highlights only the ones that intersect notable sites, the apparent significance increases even as the underlying randomness remains unchanged. Selection bias compounds the issue. Sites that do not fit the pattern are quietly ignored. Those that do are emphasized, repeated, and shared. Over time, the narrative crystallizes around a handful of alignments, giving the illusion of exclusivity. Statisticians refer to this as cherry-picking. It does not require dishonesty. It requires only enthusiasm without constraint. There is also the matter of tolerances. When claims are made that a site lies on a great circle, what does that mean precisely? Within 1 kilometer? 10? 50? On a planetary scale, these margins matter enormously. A deviation of even half a degree can correspond to tens of kilometers on the ground. Looser tolerances dramatically increase the number of apparent matches. When skeptics reanalyze proposed alignments using stricter thresholds, many dissolve. The line still exists, but its exclusivity vanishes. Numerous other sites fall just as close to countless other great circles that no one talks about. This does not make the original observations fraudulent, it makes them incomplete. Cognitive psychology offers further insight. Humans are pattern-seeking organisms. This trait was evolutionarily advantageous. Recognizing meaningful structure in noise once meant the difference between survival and extinction. But the same mechanism that helps us spot predators in foliage also causes us to perceive intention in randomness. This tendency is called apophenia, the experience of seeing patterns where none were intentionally placed. Closely related is confirmation bias. Once an individual becomes intrigued by the idea of a hidden network, evidence supporting it feels compelling, while contradictory data fades into the background. Each new alignment reinforces belief, not because it is statistically extraordinary, but because it fits an emerging narrative. Scientific critique has repeatedly applied these principles to claims of planetary grids and global ley systems. Publications and analyses summarized by outlets such as Live Science have emphasized that no proposed alignment has yet demonstrated statistical significance beyond what would be expected from random distributions of sites on a sphere. When datasets are expanded to include all known ancient structures rather than a curated handful, the uniqueness disappears, patterns multiply, networks overlap, meaning diffuses. From this perspective, the mystery seems to collapse. No lost global survey, no ancient GPS, no hidden planetary blueprint, just geometry, probability, and the human hunger for coherence. And yet, this is not the end of the story. Because mathematics, while powerful, does not fully address another dimension of the question, one that statistics alone cannot quantify. While alignments can emerge by chance, choices do not. Ancient builders chose where to build. They chose which directions mattered. They chose what to align with sunrise, with solstice, with stars, with mountains, with rivers. Those choices were not random, even if their global intersections may be. The skeptic can demonstrate that some alignments are inevitable. What the skeptic cannot dismiss so easily is the consistency with which humans across cultures return to geometry, orientation, and celestial reference as organizing principles. Probability explains how lines can be drawn. It does not explain why orientation mattered at all. Mathematics can show that a line connecting Giza and Easter Island is not extraordinary on its own. But it cannot explain why so many civilizations, without contact, embedded sky knowledge into stone, earth, and ritual space with such persistence. The intellectual trial, then, is not about whether a specific line proves an ancient global network. It is about whether the impulse to structure space according to cosmic reference points is itself a fundamental feature of human cognition. When the numbers are laid bare, the grand claims of a single hidden planetary grid lose their footing. But something subtler remains intact. Across time, geography, and culture, humans repeatedly turn to the same tools: geometry, alignment, repetition, orientation, to anchor meaning in a vast and indifferent cosmos. That pattern is not imposed by chance, it is chosen. And that raises a quieter, more difficult question, one that survives even the strictest statistical audit. If the lines themselves are coincidental, what is it about the human mind that keeps drawing them anyway? The Earth is not silent, but it is indifferent. It does not store memory in the way humans imagine memory. It does not encode intention. It does not arrange itself to be read like a message waiting to be deciphered. When stripped of romance and metaphor, the planet reveals something far more austere and far more instructive. Earth is a physical system governed by fields. Its gravitational field arises from mass and curvature of space-time, describable with extraordinary precision by Newtonian mechanics and general relativity. It dictates the motion of oceans, satellites, and galaxies alike. Its geometry is smooth, continuous, and blind to symbolism.
Its magnetic field is generated deep within the planet by the geodynamo, the motion of molten iron in the outer core, driven by heat and rotation. This field reverses unpredictably, wanders over geological time, and leaves traces only in cooling rock and sediment. It is dynamic, unstable, and fundamentally unconcerned with surface monuments.
Neither of these fields forms a fixed geometric grid. There are no permanent lines of force crisscrossing the surface in neat global patterns. Magnetic field lines loop from pole to pole, constantly shifting. Gravitational equipotentials form gradients, not pathways. No measurement, satellite-based or terrestrial, has ever revealed a planetary lattice corresponding to ancient structures. This point matters because many modern narratives quietly assume the opposite. Claims of an Earth-wide energy network often conflate metaphorical language with physical law. Terms like nodes, frequencies, and resonance are borrowed from physics but detached from their formal definitions. They are made to sound empirical while bypassing measurement. Take frequency. In physics, a frequency refers to the rate of repetition of a measurable oscillation. a wave, a vibration, a periodic motion. Earth has many such frequencies. It has seismic normal modes excited by earthquakes. It has rotational frequencies. It has electromagnetic emissions driven by solar interaction. These are quantifiable, instrument-detected phenomena. What Earth does not have is a preferred numerical value imbued with meaning. The oft-cited number 432, for example, appears frequently in discussions of ancient knowledge systems. It is linked to musical tuning, planetary cycles, architectural proportions, and even the Earth's dimensions through scaling arguments. The implication is that this number is somehow encoded into the planet itself. Geophysically, it is not. There is no natural oscillation of Earth that resolves to 432 Hertz. No tectonic rhythm, no magnetic pulse, no gravitational resonance. When the number appears in modern claims, it is almost always the result of selective scaling, multiplying or dividing known quantities until a desired value emerges. This is numerology, not measurement.
The distinction is not trivial. Numerology begins with a number and searches for confirmation. Science begins with observation and allows numbers to fall where they may. The former is narrative-driven. The latter is constraint-driven. When geophysicists map Earth's magnetic field using satellites such as ESA's SWARM mission, what they find is complexity without symmetry. The field bulges, weakens, and shifts. The South Atlantic anomaly grows, the poles drift. None of it respects ancient sites, sacred latitudes, or geometric ideals.
Likewise, gravitational anomalies, measured with exquisite sensitivity by missions like GRACE, reflect mass distribution, mountain ranges, ocean trenches, mantle plumes. They do not trace human history. This does not diminish ancient builders. It clarifies their context. When people in the past oriented structures towards solstices, stars, or cardinal directions, they were not responding to a whisper from the earth. They were responding to the sky, to seasonal cycles, to shared observation, and to cultural meaning. Their reference frame was cosmic, not geophysical. The idea that the planet itself guided monument placement arises from a modern desire to externalize intention. It is more comforting to imagine Earth as a conscious participant than to accept that meaning originates elsewhere. Because if the planet is not arranging the patterns, if there is no hidden grid, no encoded frequency, no silent instruction, then the responsibility shifts. The patterns are not found, they are made. Earth provides a stage, a rotating spheroid with predictable cycles, resources unevenly distributed, and horizons that invite measurement. It offers constraints, not instructions. Within those constraints, humans impose order. We align stones not because the planet demands it, but because alignment satisfies something in us. We draw lines not because they exist inherently, but because we seek continuity across space and time. When stripped of mystical overlays, this realization is not disappointing, it is sobering. It tells us that the meaning attributed to ancient structures does not originate in hidden energies beneath our feet. It originates in cognition, culture, and shared attention. The Earth does not remember us. It does not preserve intention. It does not care whether we notice it or not. Long after our structures erode, its fields will continue, untroubled by interpretation. And yet, humans persist in seeing patterns written across its surface. If the planet is not speaking, if it is not encoding messages in stone and magnetism, then the question becomes unavoidable. Where exactly does this relentless pattern-making come from? When the physical explanations fall away, the question does not disappear, it moves. If there is no planetary grid etched into gravity or magnetism, and no hidden energy lattice guiding stone and ritual, then the persistence of similar structures across cultures demands a different frame of reference. Not beneath our feet, but behind our eyes. Human beings everywhere live beneath the same sky. This is not a metaphor. For tens of thousands of years, the night sky was the most stable, information-rich environment available to our species. Mountains eroded, rivers shifted, forests advanced and retreated, but the stars returned night after night with a reliability unmatched by anything on Earth. From any latitude, the sky offered orientation, rhythm, and scale. It revealed cycles longer than a human life and patterns subtle enough to reward patience. To observe it was to encounter order in an otherwise unpredictable world. It is here, in shared observation rather than shared contact, that a different kind of network begins to emerge. Across continents and millennia, cultures that never met nevertheless organized meaning around the same geometric primitives. The circle appears again and again: stone circles in Britain, kivas in the American Southwest, circular enclosures at Göbekli Tepe, mandalas in South Asia. The form is simple, but its recurrence is not trivial. A circle has no privileged direction. It encloses without hierarchy. It mirrors the apparent shape of the sun and moon. It models the horizon itself, a continuous boundary between earth and sky. From a cognitive perspective, the circle is an intuitive way to represent completeness and recurrence. From an observational one, it reflects the daily rotation of the heavens around a fixed point. That fixed point, the axis, appears just as reliably. Many cultures oriented their cosmologies around a central vertical line connecting above and below. The axis mundi appears in Norse mythology as Yggdrasil, in Mesoamerican belief as the world tree, in Hindu cosmology as Mount Meru. Architecturally, it manifests as pillars, obelisks, ziggurats, and sacred mountains. This axis is not arbitrary. It corresponds to a real astronomical feature, the apparent rotation of the sky around a pole. In the northern hemisphere, stars circle Polaris. In the south, they revolve around an empty point. This slow, nightly turning invites the idea of a cosmic hinge, a stable center amid motion. Cardinal directions follow naturally. North, south, east, and west are not abstract categories. They are observationally grounded. The sun rises and sets along a predictable path. Shadows at noon point consistently in one direction. Over time, this creates a spatial framework that can be replicated anywhere on Earth. Ancient Chinese cities were laid out on strict north-south axes. Egyptian temples aligned to cardinal points with remarkable precision. Mesoamerican ceremonial centers organized plazas and pyramids according to solar and planetary cycles. Even in cultures without monumental stone architecture, directional symbolism structured ritual and storytelling. This was not coincidence, it was convergence. Cycles complete the pattern: day and night, lunar phases, seasonal changes, precessional drift unfolding over centuries. These rhythms imposed a temporal structure on human life. Agricultural calendars, ritual festivals, initiation rites, and myths of death and rebirth all map onto observable celestial cycles. The Maya long count calendar tracked time on scales far exceeding any individual life, embedding cosmic repetition into social memory. In Australia, Aboriginal songlines encode seasonal and stellar knowledge in oral form, preserving navigational and ecological information across thousands of years. None of these systems required contact with one another. They required only sustained attention to the same phenomena. This is the crucial reframing. When similarities appear across cultures, the instinct is to search for transmission, a lost civilization, a forgotten network, a shared origin. Sometimes transmission exists, often it does not. But cognitive convergence does not require contact. Given the same inputs, human perception tends to organize experience in similar ways. This is a principle well established in cognitive science. The brain is a pattern compression engine. It seeks symmetry, reduces complexity, and anchors meaning to stable reference points. The sky provided those reference points universally. The network in this light is not a set of lines crossing the planet. It is a set of mental frameworks recurring across minds separated by time and space, invisible yet consistent, not imposed by Earth, but constructed in response to the cosmos. This explains why geometry appears sacred, why orientation matters, why monuments face horizons and solstices. These are not the fingerprints of a hidden global system. They are the byproducts of shared perception interacting with shared environment. Importantly, this does not diminish the sophistication of ancient knowledge, it deepens it. To independently arrive at similar symbolic architectures without communication suggests that certain cognitive solutions are robust. They emerge wherever humans engage seriously with the sky, time, and mortality. The sense of connection we feel when tracing alignments across the globe may therefore be real, but not in the way initially imagined. It is not evidence of ancient coordination. It is evidence of human continuity. Across cultures, humans ask the same questions. Where are we? When are we? What returns? What endures? They answered with circles, axes, directions, and cycles because those forms made the cosmos intelligible. They turned observation into meaning, and that realization reframes the mystery one final time. If no physical grid connects these sites, and no planetary memory guides their placement, yet similar structures keep emerging across deep time, then the connection may not lie in stone or soil at all. It may lie in consciousness itself, weaving patterns across generations, linking minds that never met through a shared encounter with the same sky. Humanity has always lived on a short leash of perception. Days pass quickly, months flicker by. Even the longest lifespans are brief in comparison to the sweep of the cosmos. Yet across cultures and millennia, humans have found ways to perceive time on scales far longer than any individual life. One of the most striking manifestations of this impulse is awareness of axial precession, the slow wobble of Earth's rotational axis that completes a cycle roughly every 25,920 years. Axial precession is subtle. Unlike the daily rotation of the sky, it is imperceptible to the casual observer. The celestial pole, around which stars appear to circle, shifts gradually, altering the positions of constellations over centuries and millennia. Polaris, familiar to us now as the North Star, has not always held that position. In ancient times, other stars occupied the pole, and in the distant future, yet others will. The cycle is inexorable, indifferent, and slow beyond immediate comprehension. The first recorded recognition of this motion came not from mystical intuition, but from careful astronomical observation. Hipparchus, a Greek astronomer of the 2nd century BCE, noticed subtle discrepancies in star positions compared with earlier Babylonian records. From these anomalies, he inferred a slow drift, what we now call precession. His work revealed that even the seemingly fixed night sky is in motion on scales that dwarf human lifetimes. It is crucial to note that awareness of precession does not imply a coordinated global network or hidden knowledge passed from civilization to civilization. Yet the repeated attention to this phenomenon, encoded variously in calendars, temple alignments, and mythologies, demonstrates a profound human engagement with time beyond immediate necessity. The Maya, for instance, developed long-count calendars capable of tracking thousands of years with extraordinary precision. The Egyptians integrated decadal and stellar cycles into their ritual and agricultural planning. Stone circles and megalithic alignments across Europe may have registered solstices, lunar standstills, and perhaps long-term stellar motions, showing that prehistoric peoples were attuned to subtle celestial rhythms. The fascination is not arbitrary. Cycles larger than lifetimes offer a framework for situating human existence in a broader temporal context. They provide narrative continuity across generations. They remind societies that while individual life is fleeting, patterns endure. They allow humans to anticipate seasons, predict celestial events, and anchor mythologies to observable regularities. The 25,920-year precessional cycle, while imperceptible over a single lifetime, exemplifies this concept at its most extreme. A cosmic clock whose slow sweep dwarfs both kings and commoners, yet whose effect can be traced in the positions of stars and the alignment of monuments. Attempts to link precession to global networks are speculative at best. There is no evidence that early civilizations in Mesopotamia, Mesoamerica, or Anatolia coordinated such knowledge across continents. Nonetheless, local awareness of long cycles is well documented. Cultural artifacts, carvings, astronomical tables, ritual calendars demonstrate that humans were capable of observing periodic phenomena and embedding that knowledge in social and religious structures. It is the universality of the fascination, rather than evidence of transmission, that matters. Precession is also instructive because it highlights the intersection of cognition and environment. Humans have an innate tendency to detect and encode periodicity. Daily cycles are obvious. Lunar cycles are noticeable. Seasonal cycles affect survival. By extending observation over decades, centuries, and even conceptualizing millennia, humans begin to perceive patterns that are neither immediately useful for survival nor necessary for social organization. These cycles become tools for orientation, meditation, and meaning-making. This may explain why structures across cultures, despite vast geographical separation, show careful attention to timing and orientation. Temples, pyramids, and stone circles often incorporate celestial markers that track both short-term events like solstices and long-term phenomena like stellar shifts. While no global blueprint is discernible, the recurrence of interest in deep temporal cycles is striking. It suggests that the human mind is wired not just for survival in the immediate environment, but for engagement with temporality on scales vastly beyond individual experience. Axial precession also has implications for storytelling, religion, and cosmology. Civilizations interpreted long cycles as evidence of divine order, of celestial governance, or of repeating ages of creation and destruction. The concept of great ages in Hindu cosmology, the yugas, spans tens of thousands of years. Similarly, some interpretations of Mayan long-count mythology embed awareness of extended temporal scales into ritual cycles. These are not precise astronomical charts in the modern sense, but they reveal a shared intuition that time operates on levels far beyond the human lifespan. From a scientific perspective, precession is neutral. It is neither destiny nor message, yet it is also unavoidable. Its effect on stellar positions is measurable, predictable, and mathematically derivable. For the observer with patience and recording tools, it is readable. Ancient civilizations, even without telescopes, could perceive its effects indirectly through careful record-keeping and successive observation. In essence, the slow sweep of precession invites a mental expansion. It forces humans to conceive of continuity across generations, to consider knowledge accumulation as cumulative rather than ephemeral, and to situate personal existence within cycles that outlast cities, empires, and dynasties. This cognitive horizon may be the real network connecting ancient peoples, not stones or lines on the earth, but shared attention to the rhythms of a universe that is far older and slower than any one lifetime. By studying these long-term cycles, we gain insight into a fundamental aspect of human cognition. The drive to measure, anticipate, and ritualize the cosmos is not simply functional, it is existential. It positions humans as observers of a vast, indifferent system, prompting reflection on mortality, continuity, and the nature of time itself. And yet, even as we recognize the mechanics, the physics of precession, the mathematics of celestial motion, the precise timing of alignments, the question persists. Why are humans drawn so consistently to cycles far longer than their own existence? Why do we invest meaning, ritual, and architecture into patterns we will not live to witness fully? It is a question that bridges astronomy, anthropology, and philosophy. The stars rotate, the axis wobbles, the precession marches on, and across millennia, human beings continue to respond. Not because the sky commands it, not because the earth dictates it, but because the human mind, in its relentless search for order, recognizes patterns that transcend individual life. The fascination with cosmic time, embodied in precession, reminds us that the network we trace across history may not be composed of lines or stone, but of consciousness reaching outward, seeking continuity and connection with a cosmos that unfolds on its own inexorable schedule. Long before the first maps were drawn on papyrus, clay, or parchment, humans had already learned to navigate, organize, and encode knowledge in the landscape itself. Geography was memory, and memory was geometry. The terrain was a library, and the body was its reader. Oral cultures developed sophisticated methods for storing and transmitting information without writing. This was not improvisation, it was carefully structured cognition honed over generations. In many cases, entire cultural frameworks, cosmologies, and ecological knowledge were embedded directly into the topography. Sacred landscapes functioned as living archives, each hill, river, grove, or rock carrying information that was recalled and reinforced through ritual, story, and movement. One striking example comes from indigenous Australian songlines. These are not songs in the casual sense, but complex oral systems combining melody, rhythm, and narrative to encode routes across vast stretches of desert and forest. A single songline could describe hundreds of kilometers of terrain, waterholes, hunting grounds, seasonal shifts, and astronomical markers. The song provides mnemonic cues for travelers, linking geographic features to temporal patterns and mythological events. By following the song, a person could navigate across hundreds of kilometers without visual maps, relying entirely on oral transmission anchored to the physical world. Similarly, many African societies have used processional paths to structure knowledge. Ritual circuits connect sacred sites in ways that encode lineage, spiritual hierarchy, and ecological information. In the Yoruba culture of West Africa, for example, shrines and sacred groves are arranged along specific axes and connected by ceremonial paths. Initiates learn the network by moving through it, performing rites at each location. The landscape itself is a map, a mnemonic scaffold that requires no ink, paper, or measurement instrument. In North America, the ancestral Puebloans created what modern archaeologists now interpret as spatially complex networks of plazas, kivas, and roads. At Chaco Canyon, the great houses are connected by engineered roads that extend for dozens of kilometers. These roads are remarkably straight across rugged terrain, and their alignments correspond to topographic, hydrologic, and possibly astronomical features. There is no written plan surviving, yet the system exhibits large-scale spatial thinking comparable to formal cartography. The ancestral Puebloans were thinking in networks, even without maps in the modern sense. Memory palaces, also called loci systems, offer another example, though in a cognitive rather than geographic register. This technique, used in various ancient cultures from Greece to India, involves encoding abstract information within imagined spatial structures. Each room, corridor, or object within a palace serves as a mnemonic anchor. What is remarkable is that this internalized spatial thinking mirrors the logic of external landscapes. It suggests that humans are predisposed to organize knowledge relationally, whether in mind or in the environment. Memory palaces also illustrate a principle that resonates across cultures. Spatial relationships are easier to retain and communicate than abstract sequences. Sacred landscapes often combined all these strategies. In many cases, the placement of monuments, shrines, or natural features forms a coherent spatial logic. In the Inca Seque system, sacred shrines radiated outward from Cusco along imaginary lines, each connected to particular rituals, social groups, and celestial observations. In the absence of written records, the network persisted through human movement, memory, and ceremonial practice. The spatial system was encoded socially and culturally. One could navigate it, teach it, and maintain it over generations, all without a physical map. Another striking example is found in Polynesian navigation. Long before European cartography reached the Pacific, Polynesian navigators used a combination of stars, ocean swells, bird flight paths, and coastal cues to travel thousands of kilometers between islands. These navigators memorized patterns across the sea and encoded them into oral instructions, chants, and knot-based devices such as the Marshallese stick charts. The charts themselves were not maps in the Western sense. They represented currents, wave refractions, and island positions abstractly, relying on memory and relational thinking. The navigators internalized a network of information that allowed precise long-distance voyaging without written coordinates. Even in regions that later produced writing, spatial thinking often preceded symbols. Göbekli Tepe, for instance, demonstrates that prehistoric communities could construct large, oriented enclosures and complex arrangements without recorded plans. The alignments of pillars, the repetition of enclosures, and the distribution of reliefs suggest careful coordination, memorization, and planning. Humans were capable of conceiving and executing large-scale spatial systems using observation, oral instruction, and social organization alone. What emerges from these examples is a pattern of cognitive convergence. Independent of culture, technology, or written language, humans tend to externalize information into space. We encode memory relationally, map stories onto landscapes, and organize experience through axes, circuits, and markers. Space itself becomes the substrate of knowledge. This principle also helps us reinterpret claims about ancient networks of monuments. Even without a global grid, large-scale spatial organization exists. It exists not because the Earth encodes intention, but because humans are predisposed to organize experience relationally. Networks can emerge from observation, social coordination, and ritual repetition. The architecture of knowledge is embedded in movement and memory, not necessarily in stone alone. It is crucial to distinguish this from mystical or numerological interpretations. These spatial networks are grounded in observable relationships, practical knowledge, and social reinforcement. They demonstrate the intellectual capacity to handle abstraction, scale, and interconnectivity without recourse to written language or mathematical notation as we now understand it. In other words, humans were thinking in terms of connections, sequences, and relationships far before formal cartography. The ability to perceive, encode, and transmit spatially structured information is a fundamental cognitive tool. It allows societies to navigate, organize, and transmit culture across both time and terrain. This brings us to a subtle but profound insight. The invisible network we perceive in the alignment of monuments or in legendary ley lines may not exist in the ground. It may exist in human cognition. These networks are conceptual, maintained through memory, ritual, and collective attention. They are dynamic, adaptable, and persistent precisely because they reside in the mind and culture of people, not in the magnetic or gravitational structure of the Earth. By tracing processional routes, memorized landscapes, and relational orientations across cultures, we recognize that large-scale spatial reasoning is a universal human trait. From Australia to the Andes, from Anatolia to Polynesia, humans externalized knowledge into space long before the first drawn maps appeared. This was not a primitive approximation of cartography. It was functional, sophisticated, and deeply relational. And it forces a reconsideration of the way we define networks. If a network does not need lines drawn on a globe, but can exist as a system of shared observation, memory, and ritualized movement, then the very concept of a global pattern shifts. It becomes less about coincidence or secret knowledge and more about the persistent cognitive architecture of the human mind. The question lingers, did ancient builders, observing, planning, and moving across landscapes without writing, ever conceive of their work as a network? Were they aware of the relational structures they imposed upon the land, connecting sacred sites, celestial reference points, and ritual sequences into a coherent whole? Whatever the answer, one thing is clear. Networks can exist without being drawn. Knowledge can be encoded without writing. And long before maps existed, human consciousness was capable of constructing intricate, persistent, and functional systems that organize space, time, and culture. There comes a moment in every serious inquiry when the object of the search begins to dissolve, not because it was foolish to look, but because looking has changed the observer. The idea of a hidden ancient network, lines threading monuments, continents, and epochs, draws its power from a paradox. The more rigorously it is examined, the less it appears to exist in the way it was first imagined, and yet the impulse to search for it does not weaken. It intensifies. This is not accidental, it is psychological. At the center of this paradox lies a well-documented cognitive phenomenon known as apophenia, the human tendency to perceive meaningful patterns in random or unrelated data. The term was introduced by the psychiatrist Klaus Conrad in the mid-20th century, initially to describe pattern perception in early-stage psychosis. But subsequent research made something clear. Apophenia is not pathological by default. It is a fundamental feature of normal human cognition. The human brain is not a passive recording device. It is a prediction engine. From an evolutionary standpoint, the cost of missing a real pattern, a predator hidden in foliage, a seasonal shift, a social cue, was far greater than the cost of occasionally seeing one that was not there. Natural selection favored minds that erred on the side of meaning. Over tens of thousands of years, this bias became deeply embedded. Neuroscience confirms this. Pattern recognition is distributed across multiple brain regions. The visual cortex detects structure, the hippocampus links associations, and the prefrontal cortex assigns narrative coherence. Dopamine reinforces perceived connections, rewarding the brain when it solves ambiguity by imposing order. In other words, seeing patterns feels good because it is adaptive. This explains why alignments, correlations, and coincidences provoke such powerful reactions. When the brain encounters disparate elements that appear to connect, a line crossing monuments, a number recurring across cultures, it experiences a sense of insight. The experience is real, even if the connection is not causally meaningful. Apophenia is not limited to geometry or archaeology. It underlies superstition, conspiracy thinking, religious symbolism, and scientific discovery alike. The same cognitive machinery that allows a physicist to intuit a hidden law also allows a gambler to see fate in shuffled cards. The difference lies not in the presence of pattern seeking, but in how rigorously patterns are tested. What makes the ancient network so compelling is that it sits precisely at this boundary. It is structured enough to trigger pattern recognition, yet ambiguous enough to resist definitive falsification. The mind oscillates between belief and doubt, never fully settling. That tension sustains attention. Psychologists call this a meaning gap, a space where incomplete information invites interpretation. Humans are particularly vulnerable to such gaps when the subject touches existential themes, origins, destiny, deep time, collective purpose. The idea of a lost global network does exactly that. It offers the possibility that humanity once knew something profound and unified, something we have since forgotten. This narrative resonates not because it is evidentially strong, but because it addresses a psychological longing for coherence across history. Importantly, apophenia does not imply stupidity or gullibility. Highly intelligent individuals are often more susceptible, not less. Intelligence increases the brain's capacity to generate connections. Without disciplined constraints, those connections can proliferate faster than evidence can regulate them. This is why engineers, physicists, and mathematicians are not immune to fringe theories. The same mental agility that allows abstract reasoning also enables elaborate pattern construction. Cognitive science distinguishes between bottom-up and top-down processing. Bottom-up processing begins with data and builds upward cautiously. Top-down processing begins with a model or expectation and searches for confirming evidence. Apophenia thrives in top-down environments, especially when feedback is ambiguous. Ancient monument alignments are a near-perfect stimulus for this. The data are incomplete. The builders left no explicit explanations. The structures are visually striking. The timescales are vast. Every ingredient necessary for top-down pattern projection is present. And yet, here is the uncomfortable truth. Without this cognitive tendency, civilization itself might not exist. The same drive that makes us see networks where none were intended also allows us to hypothesize unseen relationships. It fuels creativity, metaphor, scientific intuition, and symbolic thought. Before any theory can be tested, it must first be imagined. Apophenia becomes dangerous only when it is insulated from correction, when belief becomes identity, when skepticism is interpreted as hostility rather than calibration. But when balanced with discipline, pattern-seeking becomes one of humanity's most powerful tools. Seen this way, the illusion of the ancient network is not a failure of reason. It is evidence of a deeper truth about the human mind. We are meaning-generating systems operating in an indifferent universe. Faced with randomness, we impose structure. Faced with silence, we listen harder. The search itself reveals the architecture of cognition. Across cultures and eras, humans returned again and again to the idea that the world is connected, that events echo across time, that space carries significance, that nothing is truly isolated. This intuition predates science, religion, and philosophy. It may be older than language. The fact that the imagined network dissolves under scrutiny does not invalidate the impulse behind it. Instead, it exposes the mechanism by which humans make sense of scale, complexity, and uncertainty. We are not merely discovering patterns, we are compelled to create them. And that realization leads to a final unsettling question, one that does not concern ancient stones or vanished civilizations, but the nature of intelligence itself. If the drive to see meaning beyond the evidence is woven into our cognition, is it a flaw we must constantly restrain, or a feature without which we could never understand anything at all? If the investigation has stripped away illusion after illusion, energy grids, planetary memory, hidden global coordination, what remains is not emptiness. What remains is us. The idea of an ancient network survives not because it is carved into the earth, but because it is carved into the human mind. The persistence of geometry, alignment, and cosmic reference across cultures is not evidence of a forgotten system beneath our feet. It is evidence of a shared cognitive architecture within our skulls. This is the transformation at the heart of the journey. Humans are orientation-seeking beings. From the moment we became self-aware, we faced a problem more fundamental than survival: how to situate ourselves within a universe that vastly exceeds us in scale, duration, and indifference. The tools we developed to solve this problem were not purely practical. They were symbolic, spatial, and cosmological. Geometry is one of the first of these tools. Long before formal mathematics, humans recognized symmetry, proportion, and regularity. These were not abstractions, they were anchors. Straight lines provided direction. Circles provided enclosure. Axes provided orientation between above and below, past and future, life and death. Geometry became a way to stabilize perception in a shifting world. When ancient builders aligned monuments, they were not attempting to encode a planetary grid. They were externalizing internal order. They were projecting mental structure onto the environment, making the cosmos legible by shaping space to reflect how the mind already organizes experience. Astronomy followed the same logic. The sky was not merely observed, it was integrated. Patterns in the heavens became metaphors for continuity and return. The rotation of stars, the waxing and waning of the moon, the march of seasons, these were not just phenomena to be tracked, but narratives to be lived within. To align a structure with a solstice or a star was to synchronize human activity with a larger rhythm. It was a way of saying, we belong to this order, even if we do not control it. Myth, often misunderstood as primitive storytelling, was the cognitive glue binding these elements together. Myths encoded observational knowledge, ethical frameworks, and existential reassurance in a single package. They transformed geometry into meaning, cycles into stories, and orientation into identity. Across cultures, the same motifs recur, not because knowledge was transmitted globally, but because the human mind faces the same constraints everywhere. Limited lifespan, vast surroundings, incomplete information. The response to these constraints converges. Cognitive science supports this convergence. Humans construct mental maps automatically. The hippocampus, a brain structure central to memory and navigation, organizes information spatially, even when the content is abstract. Time is conceptualized as distance. Relationships are imagined as proximity. Hierarchies are visualized as vertical structures. We do not merely think in space, we think through space. This is why networks are so compelling. Networks reduce complexity without eliminating connections. They preserve individuality while implying belonging. They offer structure without central control. From a cognitive standpoint, networks are optimal representations of a world that is interconnected but not neatly ordered. The ancient network, then, is not a false idea. It is a mislocated one. It exists not as a physical lattice, but as a recurring mental model, a way of understanding reality that humans independently rediscover when faced with scale, uncertainty, and awe. This reframing resolves the paradox without diminishing the mystery. There was no forgotten super-civilization mapping the globe, no encoded frequencies humming beneath the stone, no planetary consciousness guiding builders' hands. And yet something real persists. Humans everywhere turn to the same strategies: align with the sky, impose geometry on space, encode memory into landscape, and tell stories that bind time into cycles. These strategies are not arbitrary. They are adaptive responses to the cognitive challenge of existing in a universe too large to intuit directly. Seen this way, ancient monuments are not messages sent across time to us. They are mirrors. They reflect the structure of the minds that built them, minds not fundamentally different from our own. The same impulse that drives modern humans to search satellite imagery for hidden patterns once drove ancient humans to raise stones toward the horizon. We are still drawing lines. We are still seeking alignment. We are still mapping meaning onto vastness. The difference is not in the impulse, but in the language we use to describe it. Science disciplines the search. Philosophy contextualizes it. Psychology explains it. But none of these extinguish the underlying drive. Because the drive is not to find a network, it is to belong to one. To know that our thoughts, rituals, and constructions are not isolated accidents, but part of a larger intelligible order, even if that order exists only because we are the ones perceiving it. This realization is not disenchanting. It is clarifying. It tells us that meaning is not discovered fully formed in the world, nor imposed arbitrarily upon it. It emerges at the boundary between perception and reality, between the sky as it is and the mind that watches it. The ancient network was never supposed to be found in the ground. It was always inside us. And if that is true, if geometry, alignment, and cosmic symbolism are expressions of a shared cognitive inheritance, then the final question is no longer about ancient builders or vanished knowledge. It is about identity. What does it mean to be a species that cannot stop searching for order in chaos, connection in distance, and significance in silence? What does it say about who we are that even when the network dissolves, the need to imagine it remains? Even as science has demystified the earth and sky, the myth of a hidden global network refuses to vanish. It persists in documentaries, books, and online forums, not because the evidence supports it, but because the human condition makes such myths irresistible. One reason is profound disconnection. Modern life has abstracted us from the landscapes our ancestors navigated, the sky they observed, and the rituals that structured time and space. Concrete experience has been replaced with screens, cities, and schedules. In a world where orientation is mediated by smartphones and satellites, the imagination seeks tangible connections once embedded in the world itself. Myths of planetary grids and secret alignments provide a bridge, an imagined continuity linking us to a lost perceptual world. Technological abstraction compounds this effect. Global positioning systems, satellite imagery, and orbital mechanics make the invisible mathematically legible. Lines are plotted across continents, trajectories are calculated with sub-meter precision, and spacecraft navigate according to laws of motion first glimpsed by Kepler and Newton. These modern networks are real, measurable, and precise, yet they evoke the same conceptual frameworks our ancestors used: alignment, trajectory, and relational geometry. The mathematics of GPS, great circles, ellipsoidal corrections, orbital paths, resonates uncannily with the forms once thought to appear in stone, earth, and ritual space. We see parallels between our technology and the symbolic structures of the past, reinforcing the myth of continuity, whether or not one actually exists. Another factor is loss of cosmic context. In pre-modern societies, humans were acutely aware of cycles that exceeded individual lifespans: solstices, lunar phases, precession, and the migration of stars. The universe was a clock, a calendar, and a canvas all at once. Today, the motions of Earth and sky are reduced to numbers on a chart or lines in software. The experiential engagement has been lost, replaced with abstraction. The human mind, however, craves connection to scale and rhythm. Myths of hidden alignments satisfy that need by translating enormous spatial and temporal patterns into stories, diagrams, and symbols that the imagination can grasp. It is telling that even the most skeptical commentators often describe the network metaphorically, as if it were a lens for seeing human cognition projected onto the world. The desire for a hidden order is less a question of evidence than of meaning. It persists because it fulfills an enduring need to locate ourselves within a cosmos that is otherwise vast, indifferent, and overwhelming. Ironically, modern technologies replicate ancient perceptual strategies. GPS satellites trace paths along great circles. Orbital mechanics relies on the same spherical geometry that underlies archaeoastronomical alignments. Engineers and navigators are, in effect, re-engaging with the geometric intuition our ancestors applied to align stones and monuments, but now with instruments, equations, and computers. We have outsourced the observation to instruments, but the underlying logic, the search for orientation, relationship, and predictability, remains fundamentally the same. The persistence of the myth, then, is not evidence of global conspiracies or lost civilizations. It is evidence of a persistent cognitive and cultural trait. Humans naturally seek patterns, continuity, and order. We externalize cognition into the landscape, the sky, and now into our technology. We return again and again to the same forms: alignments, axes, cycles, networks. They echo across millennia because they are deeply adaptive, psychologically and culturally. The myth survives because it is not about the world outside, but about the world inside. It is a reflection of our consciousness reaching for coherence. Ancient builders may not have known a network existed, but they were shaping structures that mirrored the way their minds interpreted the cosmos. Today, we plot satellites, map flight paths, and align observatories, unknowingly repeating the cognitive processes of our distant predecessors. And so the cycle continues. The narrative is compelling, regardless of factual grounding, because it fulfills the same function now as it did then, providing structure, orientation, and connection in the face of vast, impersonal systems. It is a myth born of human need, refined by technology, and perpetuated by imagination. The unresolved question lingers. As we trace lines across the globe and calculate orbital paths, are we rediscovering the same principles that once guided ancient minds? Or are we inventing something entirely new in response to our modern abstraction? There is a temptation at the end of any long search to feel disappointment, To expect revelation in the form of a hidden map, a buried code, a final proof that something extraordinary was deliberately concealed. But the deeper truth rarely arrives with spectacle. It arrives quietly, almost reluctantly, when every other explanation has been stripped away. There was no secret cabal guiding humanity from the shadows. No lost super-civilization spanning the globe. No planetary energy grid humming beneath stone and soil. What existed and still exists is something both more ordinary and more profound. The true network was never external. It is the shared human impulse to seek order in chaos, to align what we build with what we observe, to place meaning where the universe offers none freely. Geometry, astronomy, ritual, and myth were not fragments of a forgotten system. They were tools, ways of orienting fragile minds inside an incomprehensibly large cosmos. Ancient builders did not encode messages for the future. They encoded themselves. When they aligned stone to solstice, it was not to signal hidden knowledge, but to anchor time. When they arranged monuments around axes and circles, it was not to map the planet, but to make existence intelligible. They stood between earth and sky and tried, as we still do, to understand their place between the two. The patterns we trace across continents today are echoes of that same impulse. The reason they feel powerful is not that they reveal something secret, but because they reflect something familiar. We recognize them instinctively because we are still doing the same thing, drawing lines, searching for coherence, imposing structure on immensity. The ancient builders were not hiding something from us. They were reminding us where we stand. On a rotating sphere beneath a moving sky, aware for only a moment, yet compelled to connect moments into meaning. They understood, perhaps without words, that survival alone is not enough. Orientation matters, memory matters, shared reference matters. The network no one was supposed to find was never buried in the ground. It was always active, carried forward in every culture that looked up, marked a horizon, told a story, and built something that outlasted a lifetime. And now that network includes us. For the first time in history, humanity can see the planet whole. We map it, monitor it, alter it. Our patterns no longer end at ritual or monument. They reshape climate, ecosystems, and the future itself. The impulse to impose order has scaled beyond stone and myth. Which brings us to the final unsettled truth. If meaning is not discovered but created, constructed collectively across generations, then it is not neutral. It carries consequences. The ancient builders left no instructions, no warnings, no blueprints for what comes next. They only demonstrated the impulse to align matter with meaning and meaning with the cosmos. The question that remains is not about the past, it is about responsibility. If we are the inheritors of this shared human network, this ancient drive to make sense of the world, what do we choose to build with it now? Thank you for joining us on this extraordinary journey through the universe on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us where we unravel the darkest mysteries of space.